Hello everyone, this is Vishnu from Institute of Aeronautical Engineering, Hyderabad. And for my compiler design tech talk, I have chosen deep learning takes on translation topic. And let's get started. So, what exactly is even meant by translation? So, uh, over here, I mean, in this context, it is nothing but the conversion of sentences um, from one language to another language without changing the meaning of the sentence. So this is what translation is meant. So what is deep learning? And deep learning is most commonly used in unsupervised datasets, where unsupervised datasets are those which doesn't have any meaning. Let's say like if you have uh, found a new object in space, we can take the picture of it and well, it's an undefined object, so we don't know what it is, but we have a few parameters uh, to let's say like to say whether it's a meteorite or a space debris or an, anything else or a planet. So we don't know what exactly that object is, but we know a few parameters of something which makes of something else. So we pass in this image. So we can call this image as unsupervised data, and for and we can send um, or we can also take another example like we don't know what is a bus is, so we have a n number of bus pictures and m number of car pictures. Then if we feed into the to the neural network, then it will predict or it can define what the difference, like it will not be sure that yes, this is a bus, but it is intelligent enough to say this is different from the other one. So if you pass on a bus picture, it will categorize it as bus, or it will consider it as bus because of the shape and all the features that the bus has, which are different from what car has, like the body shape and size. Size doesn't matter when it comes to images, but uh, we can consider one of that when pictures are taken with constraints, something like that. So that's what is unsupervised is. So deep learning is very good at it, and deep learning consists of neural networks which has an input function and an output. Inputs are or can also be a normal input, or it can also be a weight, and a function is nothing but it decides on based on the weight whether to fire the neuron or not, and the output is nothing but the product of the function. So machine learning has its limitations as it is based on formulas. So in machine learning, we basically use formulas to interpret the data, and it's very good at it's very good at supervised data sets, uh, but not with unsupervised data sets. And this translation is a field where it's completely different, where in such actually the way we construct our sentences, the meaning will keep on changes. So there are a number of factors that we have to keep in mind so that we'll get the optimum sentence or optimum results. So for those reasons, machine learning is not at all a feasible option. Well, it used to be in past, but because of hardware incapabilities, because hardware was incapable enough to uh, have or build or can perform operations um, with neural networks. But now, since we have the capabilities, the hardware capabilities, we are using deep learning for these such problems where there are n number of unknown parameters or known parameters, but it takes a lot of time and effort to develop with the help of machine learning algorithms. But with the help of deep learning, the model itself will learn with respect to the inputs. So that's why deep learning over machine learning. And neural networks can learn and adapt their weights, which makes it the perfect go-to choice for the complex real-world applications. Since a complex application would have a number of known and unknown variables which actually matter and alter the behavior of the current output. So for those reasons, a deep learning model is well suited rather than a machine learning model, because uh, it's not feasible to build a machine learning model in this day because we have the processing capabilities. Moving on. So the way of approach to solve the problem of detecting the meaning and intent from one language and translating the same into the another language. So that's the problem. Um, so this is from a paper. So the specific analysis a particular network performs depends on the numerical weights assigned to each interconnection and on the details of how they combined output is computed. Challenge is to set the parameters for a particular task by exposing the system to a larger series of inputs, which is nothing but the n number of data sets, um, so that the model can learn effectively uh, and desired outputs are known. So this is not a kind of a unsupervised uh, algorithm, but unsupervised data set. But over here, we know the inputs and we also know the outputs. That's typically a supervised data set. Where in supervised data set, we know the input and we also know the output. We are just making a model to learn on it. So over here, we are doing the same, where we know the inputs and we also know the outputs. And this input and outputs data is fed into a neural network. So, and sequentially adjusting the parameters to reduce any discrepancies, discrepancies. Yeah. So, after such training with known examples, the network can quickly extract high-level information from a novel low-level representation with a large enough set of examples. This training can be done without even specifying which features are needed for classification. Uh, so basically after since our model knows the inputs and the outputs and after adjusting the parameters and the bias for the neural network, the model can now actually predict and construct the same sentence or the same meaning of a sentence of one language into another language. And thus optimizing the performance of a translator. And Google has recent not recently but started to implement this same deep learning methods in their Google Translator.